Yeah. Yeah. Okay, so we can start, sir. So we are recording now.
Okay, so so this one is the Excel 5 for how many works are here? 27.
Good. Yeah, 79.
79.
Yeah.
How many works were included for the study?
Okay. It was 128 or so.
128
Yeah.
studies
Yeah.
were included for the systematic review.
Yes. Then along the line, you now notice that some works are actually they didn't meet the inclusion criteria. So in the full, yeah, so we had to exclude them.
Have you updated the flow chart, the Prisma flow chart?
Yes, yes. Oh, yes.
Okay, so in the flow chart now, it's recorded that it's only 79 studies that are included for the systematic.
Include. Yes. Yes.
Okay. So for the data extraction, you will have normally I have what I call the data extraction table or two, which is basically a table. I don't know if we went through it the last time.
Yes.
Yeah, so a table containing details you want to pull out from the primary studies that you are including.
So,
Which was the topic of this particular work?
this one is the gamification.
Okay, so
Yeah.
did you create any table for this one?
Yes, I created table. So, but to make it more organized, I had to use Excel.
Okay.
Yeah.
So what were the datas you were extracting from the primary
Yeah.
study? I can see
Yes.
the location, the type of study. I don't know what is under G. I'm seeing chronic and subacute. So if you can just run through like the details, details of the data you extracted.
Okay. And auto like from our last class, what we basically need author, yeah, country,
Yeah,
study design,
yeah.
then intervention, and then comparison.
Okay, sample
Comparator,
size,
sorry. Yeah.
intervention, primary outcome, secondary outcome. Okay, yes. So with these values now, this is what we help us um, in writing our chapter 4, which is the result. So basically, the most difficult parts, kind of the hands-on for this study is almost done. So the remaining part is now the kind of the intellectual work where you have to kind of, based on the information you have, write uh, a, how will I put it? Arrange these values in academic, professional way to kind of state explicitly what the results of your findings. So this is basically more of what you've identified. So these are your findings, these are your results. Before we go to the results, I know we've written this thing, what is it called? Protocol, which
Protocol,
is
yes.
basically more of a chapter 1 and 3, or for some persons, just the chapter 1, depends on how, whatever way you wrote it. But the chapter 3, which is the methodology, will be just you explaining everything you have done up till this point. So if we want to do a meta-analysis, then that means our hands-on have not stopped. We would now need to create a different table to do the meta-analysis. But meta-analysis, for me, I'm not so good with it. So the previous studies that I've done, what I usually do is just to create the table, send it to Ibeneme, then Ibeneme have someone that he usually send them to that runs the analysis. I think they usually use Revman to do the analysis. So I've not done meta-analysis, like run the computation myself, done the actual analysis myself. The only thing I know, if I create the tables that will be used to do the analysis, and then once you have that, what's that graph called again? The Revman, once you run the analysis, it will give you, oh my God, my brain. It will give you um sorry, I'm just trying to think. But when you run analysis on something like SPSS, that graph that you get, for those that do primary studies,
Yeah.
what's the graph called?
It's not the pictogram and what's
Yeah,
the
all
thing
those
called?
different things. But for meta-analysis, there is a special name. Let me ask AI. So what that graph does is just a pictorial representation of summary of the meta-analysis. It tells you works uh, that have significant differences and those that do not have significant differences. It have two sides, the negative and the positive side. And then there is uh, a diamond shape that kind of is more like the merging together of all the outcome. Like it's more like when you've added all the outcome together, what the cumulative effect will be, kind of. My problem is just trying to explain it.
Is it forest plots?
Thank you.
Mm.
Thank you. So that's the forest plot. So the forest plot will give you all those values. So, and then explaining the forest plot is more like interpreting the meta-analysis.
Okay. But
So
I want to ask,
yeah.
how can you now get the forest plot?
So
Is it
that
from
you get it from or any application that you can use to do the meta-analysis, that you can use to run the meta-analysis. Something like I know about Riveman for sure, but I don't know about other ones.
okay?
I don't know why Prince is not here because he's the data analysis guru. This could have been his part.
Yeah, it's part. Okay,
No,
it's all right.
me, I they run from data analysis, so I know Sabi Mass.
Okay, it's all right.
But once I have the forest plot, I know I can interpret the informations there.
Okay, okay. So, but if we don't want to do the meta-analysis, can we
Okay, so
progress without it?
I've just checked. You can run the forest plot with a R, Revman.
R.
Yeah,
Okay.
Revman, like I said. You can also run it with starter, graph.
Starter.
Yeah, all these things are similar to SPSS. They are just
Okay.
tools for running analysis.
Okay. So it's just to from this table now, copy it and put in the right man.
No, you not just copy the way you need to create a different outcome table because what you need is just numbers like figures. It doesn't need words.
Okay.
So because what you are doing is just imputing those, typical sometimes you may need words to kind of explain what you need. Just like when you are doing your SPSS analysis, maybe
Analysis.
if you are
Okay.
saying population or calling this orange, but then you know that the measured thing is the data. Like you have to put in that data can be words or number. You know, for those that are into and all these analyses, that's where you start thinking about integers, whatever, whatever. Me, all those things now, what me, even though not chairman.
Okay.
Sir,
So you can also, yeah,
sir, the tools you mentioned earlier for the data analysis, are they a website or they are an app that we are going to download?
some of them are app, and so just like most app, they have their online version. So things you can even run it with Python from what I'm seeing here. You can run it with Python. You can run it. I know Revman, there is an app. Revman is just the short form for review manager. Is an app
Mm.
for running is Revman is basically for systematic reviews and meta-analysis. Then starter, you can run starter. You can do it with starter, but you can use starter to do like your normal primary studies. It also runs statistical analysis like SPSS. But I think in addition, it can run meta-analysis and create forest plots.
Sir, how do you call it again? Refman.
Revman,
REV.
Revman.
MAN.
Yeah,
Okay, sir.
I think it was created by Cochrane. So, but let's not. For me, I will say let's not go there because I can't teach what I don't know. We get
Okay. Yeah.
if whenever I don't know how, like if Prince have gone into start doing those things, but he's more knowledgeable in regards to analysis. So analysis is more like of his thing. Me, I prefer my narrative synthesis where I
Synthesis.
will
Okay.
just use word and explain my finding. meta-analysis is just the opposite of narrative synthesis. Instead of just
Interesting.
using words, you use figures, you use data to explain the result. Even though you have the problem, even with the meta-analysis, after putting all those figures, you are still going to use words to still describe
Right.
whatever you've identified. The only difference is that meta-analysis is more objective, kind of, and then narrative synthesis is more subjective to some extent. Why I'm using to some extent is that already we have data, so there are some level of objectivity in both of them. So the easiest way to explain this thing now is in narrative synthesis. Let's use the simple analogy example I usually use. You are coming out to prove that paracetamol can cure headache. You've gathered all the primary studies done in different locations about using paracetamol to cure headache compared to other medications or no medications at all, or maybe placebos. So when you have all this information in narrative synthesis, you will just present your findings in words and the figure in those primary studies, saying, maybe at the end of the day, you are using 10 studies for your systematic review in regards to that topic. And then you are saying, okay, out of the 10 studies that study the effects of paracetamol in curing headache compared to other medications and placebos or no medications, 7 of them found significant difference for paracetamol curing headache. Why there was no significant difference in 3? That's in this simplest summary. That's narrative synthesis for you. But what meta-analysis we do is, meta-analysis, we pick those figures of significances in the 10 studies, compare it together mathematically, and then find a simple number that will tell us for like that we generalize in terms of saying, okay, I've taken the number, I've compared the population in study A. In study 1, I've compared the number of the population in study 2. I've compared the population in study 3 up to study 10. I've compared the value of the significance difference, the value, that's the number, for study 1 to 10. I've compared the mean difference or the significance difference. I've compared the error. I've done all this comparison among these 10 studies, and this is the final number explaining that even like you will have, so on the forest plot now, you will have those 7 studies that were significant will be on a particular side of the forest plot, and then there will be a central line that we kind of try to differentiate through significant, that we try to explain studies that are significant against those that are not significant. So it will now look at how far each of those studies are. So those ones that are significant, how close are they to that central line? And then there will be a bigger diamond shape. That's the one that compared all of them together, that will tell us whether by combining all those studies, the values of those studies, is paracetamol actually significant in curing headache or not? I don't know if my explanation makes any sense.
Yeah, it does.
Yeah, so meta-analysis is just the mathematical way of proving what you've find out in your systematic review. So you are kind of, and then the other thing, there are other things to consider with meta-analysis. You will now start thinking about what we call heterogeneity and homogeneity. Heterogeneity in the sense that these different studies may use different outcomes. So when they are using different outcomes, for example, if study one use VAS to measure pain and study two use a different outcome measure to measure pain that is different from VAS, that's heterogeneity because they are using different outcome, because at the end of the day, those values will still be computed together. So you will also do a test for heterogeneity in your meta-analysis and still explain how that has affected the result. But then for homogeneity is when some studies use the same outcome measure to measure a particular outcome. So all those things come into, like, there are different things that would affect the results, what you will obtain in your meta-analysis. So but let's just leave that one now. It's just, this one is basically to give you a rough idea of the difference between meta-analysis and uh, narrative synthesis. So once we have this table now, we can go on to do write our methodology, like I say, which is basically explaining the step by step what we've done so far, uh, starting from uh, how we developed our search strategy, the number of databases we searched, the number of studies we identified, all those information on the flow chart, explain everything in writing, explain what type of analysis we are going to use, explain the values we extracted for our data, how we extracted the data and everything. Basically just words explaining what we've done. Then in the chapter 4, we'll start comparing these data that we've obtained. So remember, in meta-analysis, the comparison is done mathematically, but in narrative synthesis, you explain it with words. So when we are now writing the chapter 4, it will be things like, um, for example, Colombo et al. 2007. Or maybe you can start by, after checking all these 79 studies, we identify, okay, maybe how many works were done in US, how many works were done in UK, how many works were done in Japan, how many were done in Germany. So all these things, we are going to explain them in writing. For example, out of the 79 identified studies, 10 studies were from USA, 7 were done in the UK. Either we use this number or we use percentage. So the whole thing is all about empirical figures. Or you can say 10% of the study were done in the US, or 7% of the study were done in the UK. So you give an empirical figure telling the different countries where the studies were done. Give an empirical figure explaining the different study designs in the study. Then give the total sample size. So we're going to add the sample size of the individual studies together. Find percentage of male in the studies, females in the studies. Some studies may not report these values. So the ones we don't know the value, we explain that, okay, maybe 17 studies did not report on the population. All those information will explicitly give them out that these percentages, did this, these percentages did that. We couldn't find this, these were not reported. And then we'll give an empirical figure about the population, give an empirical figure about the intervention, and excuse me, and the comparators. Then when we now come down to the outcome measures, we also give the empirical figure for the primary and secondary outcome. On that, the further thing we'll now do is we'll compare, we'll give empirical figure of the key results. So when we are giving the empirical figures of the key results, that's where the effect size we come into kind of support that. So if we are saying Columbo et al. Had a significant difference, we will now put the effect size to show that. If we are saying Acosta et al. Had a significant improvement, we'll put the effect size to prove that. If the effect size is not reported, we explain that the effect size was not reported. Then, after doing that, we'll also do the risks of bias assessment. So the risks of bias assessment is another hands-on. I just remember that one now. It's another hands-on where we are going to compare. I usually just use Cochrane risks of bias too. Sorry, not Cochrane, Pedro scale. Just because it is more easier and more objective. There are other risks of bias too, but most of them are subjective to some extent. But Cochrane is just very clear. It has 11-point grading, but one of the grades, which is the eligibility, does not count. So at the end of the day, is a score of 10. So there are gradings for, I think, 1 to 3 means that the quality of the work is poor. Up to 5 to, I think, 5 to 6 is 4 to 6 is moderate. Then 7 and above shows the quality of the work is of high quality. So the risk of bias is just a tool that tries to point out the bias in each study. Remember, when we started, I said something about systematic review trying to help to eliminate bias. Not just systematic review. Every study, every research study, try to put in effort to eliminate bias as much as possible, because we are human, so we are error prone. We are bound to make mistakes. and we are bound to be biased as well. So just like we are doing here, there are some, instead of doing some things the right way, you may be like, this will take eternity. Let me just take the shortcut and avoid stress. So those shortcuts that we are taking and avoiding stress are creating bias, which cannot prove the true nature of something. Remember, research is about trying to allow nature to speak for itself. So we don't know, we've identified the problem. We don't know the answer yet, but we guess that this might be the answer. So we are now experimenting, comparing our intelligent guess with a control to see whether it is true or not. So if it is true, then it becomes a theory, but if it is not, then we may have to modify our hypothesis, all those uh, primary stage stuff. But if we don't eliminate bias from the processes, we may end up saying that this thing is true. Meanwhile, it is actually false because of the biases there. So when we are talking about bias, you are looking at selection bias. For instance, if I'm doing a primary study and I want to, excuse me, and I want to recruit uh, the same example I gave, I want to recruit people to check if paracetamol is curing headache. If I go and recruit people who don't have headache, already there is a bias in my work. So at the end of the day, whatever my findings are at the end of my research will not show the true value, the true effect of paracetamol. So one, I have to make sure that I recruit people with headache. Two, I also have to do what we call randomization, because if I don't randomize, I may end up having some people who will just tell me yes that they don't have any pain, because there is no objective way of measuring pain. I'm not aware of any clear objective way of measuring pain. So to some extent it's subjective, in the sense that it is a symptom, it is not a sign. It's what the person is telling you. If you're having headache, there is nobody that can feel your headache. You are the one feeling it. So if somebody, maybe someone in the study, you do your, if you divide them into group, and in most of the group, you have people that, due to their personal values or the kind of character they have, they would just tend to tell you that they no longer have headache, just so that the whole thing will end, or maybe to make you happy or to please you. At the end of the day, the true value of the research will not be true. So you will end up finding that you're in your research that paracetamol cures headache, but meanwhile, most of the people in that intervention group, it did not cure their headache. They just told you that it cured their headache, and you don't have that. Uh, you can't tell. So what randomization does is it tries to allow nature again to pick, to do things for itself. So you are not the one selecting who will be in the intervention group or who will be in the control group. So nobody can tell. So nature is just doing itself, natural selection, picking who will be in the intervention group or who will be in the control group. So normally you know how to do the randomization process, either by using a oblique envelope. That's an envelope that is covered, that will tell the participants which group they belong to. Or you use a random number generator. So each that we now naturally select who will be in the intervention group or control group. So you don't have power over the selection process. You don't have any bias. So that by doing that now, there is elimination of that selection bias there. Also, another bias that comes in primary studies, especially intervention studies, is risk assessment or assessor bias. Sometimes they call it the therapist bias. So there is a therapy bias and there is an assessor bias. So depending on the type of work, they may be different, but in Pedro's scale, there are two different things. So in the therapy or therapist or intervene, like the person who will actually give the paracetamol or who is carrying out, who is doing the study, they don't have to know who is in whoever that is in different group. So if I'm conducting this study about paracetamol curing headache, I should not know that Mr. A is in the intervention group, and I should not know that Mr. B is in control group, so that my personal bias will not affect the results of the work. Also, whoever is running the analysis, those are the assessors. The person that will do the data analysis should not know those in the intervention group, and they should not know those in the control group. What they have is data, run the analysis, give the results, then run the other analysis. When they are running this analysis, they don't know which group is which group. So that's them eliminating that assessor bias. Um, then also you have there are many biases for Pedro's case. They also look at the outcome measure you are using and whether the statistical figures. They also look at what they call intention to treat analysis. Intention to treat analysis tries to eliminate the bias that comes from attrition rate, whereby maybe you recruited 100 people for the intervention, and at the end of the day, 10 persons dropped out before the intervention was completed. So at the end of the day, you just have uh, 90 people that completed the intervention. So intention to treat bias, if you want to eliminate that bias from that dropout, you are meant to run the analysis with the 100 persons that you recruited, even though you don't have data for the 10 person, or you just have some extent of data for the 10 persons that dropped out. As long as you have a particular set of data, you still have to run that analysis with the 100 persons that you've collected the initial data from. Because when you've collected the initial data for 100% and then start running the analysis and drop down to 90, it's going to affect the whole result. So you have to like have that intention to treat that analysis like that you are still working with 100 persons, even though 10 have dropped out, but you are still going to put in, like, you are not going to forge any data for the 10 persons that drop out. You are just going to put that, okay, let's say the initial assessment, they came and this was the value. This was the data from whatever assessment you did. The second time they were not there. You will leave it blank and run that data blank with other ones. So for every primary study that did intention to treat analysis, they will always write it in their methodology that they did an intention to treat analysis, or you can find out by if the final number of persons they run the analysis is the same as the initial number they started with. So that's how you know whether a work did the intention to treat analysis or not. Also, what again did they look at? Can someone just open the Pedro scale? Bankole, if you can open the Pedro scale just so everybody can see what I'm saying. William, when did you say is the time for the match?
It's by 5. They have started.
I don't start to. I'll continue.
I'm enjoying the class.
Make you not belly.
Right. So I have a question.
Yeah.
Yo, so for this narrative synthesis, we are going to narrate every work one by one till the 79th work.
Yes. So it's a kind of a collective comparison, but you are still doing it one by one. For example, now there are 79 studies. Out of those 79 studies, you either run it in percentage or you run it in the integral numbers by saying, for example, the country. You would tell the readers how many studies were done in US, whether it is 7 if you are giving it in numbers, or whether it's 10% or 2%. So you will run it for instance now, even though you are doing it like you are counting out of the 79 studies one by one, how many of them were done in the US, but at the end of the day, you are not just writing down like from 1 to 79. So obviously, what's it called? There will be frequency in what you are reporting. So
Okay.
this is more like um 7 studies were done in the US, 5 in UK, 2 Germany, 1 Switzerland. You can even save yourself time. Maybe if there are the one maybe say 2 studies in other countries, and then maybe specify the countries, or one individual studies. One study were done in Switzerland and Nigeria respectively, like things like that, just giving a frequency of how those data appear. So it's just
Okay.
an empirical representation of what you've find out, like what you found out in your data extraction, because
Okay.
you didn't have that information until you completed your data extraction.
Okay. It's all right. Thank you. So another question I have is,
Yeah.
this meta-analysis can actually be done with AI. Is it advisable that we test it with AI to see what we can get, and know whether we can produce forest plots?
Like I said, like I'm not an expert in meta-analysis. I've been avoiding it all my life. So
Okay.
so anything meta-analysis, the only thing I know is once I have the forest plot, I can interpret what is there.
Is that
I
okay?
can help
Okay.
with what values you need to get, but I don't know how you will do the computation because I've not done it before.
4. Okay. It's all right. We'll see what we can come up with because AI can do magics now, honestly. It can actually do serious magics.
As well.
Oh,
So
yeah.
this is an example of a work that have been graded
Okay.
using Pedro scale. So you can look on the criterion side, there are there should be 11 points. 1, eligibility criteria. 2, random allocation. 3, concealed allocation. 4, baseline comparability. 5, blinded part participant. 6, blinded therapies. 7, blinded assessors. 8, adequate follow-up. 9, intention to treat analysis. 10, between group comparison. And then 11, point estimate and variability. Then under it, you have the total Pedro score. So for this first study, is it Tenel, whatever? Don't know how to pronounce that name. So for that first study now, like I said, the eligibility criteria does not count out of those 11 points. So you only count with the 10 points. But eligibility criteria is still part of the criteria you look at. So you still have to include, sometimes you include it. Me, I don't usually include it in when I'm doing my work just because it doesn't count. And if my work is with I know that most studies do like have eligibility criteria. Only few may not have. For example, in this year example now, only one did not have eligibility criteria. So most studies we usually have eligibility criteria. Then talking about the random allocation is what I've explained before. Uh, it's just asking whether in each of those studies was there a means, was there any explicit explanation to prove that the allocation in the study were done randomly. So if there is any proof that there was a random allocation, the study gets a score of 1. Then concealed, so I've not explained the difference. 1, you can randomize allocation without concealing it. For example, how many are you here? 4, bar. We are 4 here. If I divide this group into 2 and I say, I want to do it randomly, I can either pick, draw, if we are together physically, I can write number 1, 1, 2, 2, and put them in a paper, squeeze it together so that nobody will know which group, like what is in each of them. Shake it, put it on a table, and tell everybody to come and pick. So if after picking, if I tell you, oh yeah, open your paper so that you will know which group you belong to. I've done a random allocation, but it is not concealed because each of us are going to know the group we belong to. I don't know if that makes sense.
Yeah, it does. Yeah.
Yeah. So the allocation is random, but it is not concealed. But if I did, rather than telling you to open the number to see which group you belong to, if I get someone, a different person who is not going to be involved in the study, and ask them to divide the group for me and put each of the grouping let's say the same 1122, rather than squeezing it in a paper, maybe put it in a concealed envelope and give it to each of us. So the person who is doing this allocation knows where each of us belong to. But remember, they are not going to be, their job is just that allocation. After the allocation, they have nothing to do with this work again. So they will put us in that group, and then we that are in the group, we don't know which group we belong to. The people that are going to carry out the intervention does not know which group we belong to, but we have this concealed envelope that have already divided us into groups. Do you get? So now we've done a random allocation, and the allocation is concealed because we don't know we don't even know whether we are in the intervention group or control group. That's why some studies have these placebos as well, to tell people, like kind of to confuse people the more. You will have people like for this paracetamol intervention, some persons will take something that looks like paracetamol, but it's not paracetamol. It's just ordinary uh uh ordinary
Talk.
chalk or whatever that doesn't contain anything, that will not have any physiological effects, that will just go down the system, and the body will break it down and it will leave the system without having any effect. So the person, so that's for the concealing the allocation. So when the allocation is concealed, that means the participants don't know which group they belong to. Then most of the concealed allocation, the participant may be blinded, but in some they may not be blinded, just like in this example. For example, people may do the concealed allocation. After concealing the allocation, at the end of the day, they will now explain to the participants that, okay, you are in the intervention group, you are going to take this medication, you are going to take this medication, and then tell the other group, you are in the control group, you are not going to take any medication, you just, after 2 weeks, you will come back and will assess your pain again and see what's going on. So now the participants are not blinded because they now know the group they belong to and they know what the intervention is all about. Normally, the participant, initially, when you are recruiting, you will explain to them what the study is all about. But then you explain to them that if you want to blind a participant, you explain to them that they are not going to know which group they belong to until the end of the uh, study. But if by any chance you explain to the participants and they know whether they belong to the intervention group or control group, then the participants are no longer uh, blinded. And another thing to know about blinding participants, some intervention makes it difficult to blind participants. For example, if you are giving someone exercise, there is no way they will not know that they belong to the intervention group because they are doing the exercise. And then if you are telling another person not to do anything, just to rest, they obviously will know that they are in the control group, even though you've not told them that they are in the intervention group or in the control group. So the nature of intervention also affects. So if it is this medication kind of stuff, They may not know because even after the intervention, if they come out and try to chat together, and normal human beings, they will be like, what did they give to you? What happened? They will just say, I was given a particular medication and was asked to take it with water. They will say, it was the same thing that they did to me. So they don't know who took the real paracetamol and who took the placebo. That's for blinding participants. Then blinding the therapist is that whoever is dishing out that intervention should not know the group. So for the paracetamol one, whoever is giving the real paracetamol and the placebo should not know which one they are giving. They just know that they've been handed this thing and asked to go and give it to these different people. They shouldn't know the group that are taking the paracetamol and the group that are taking the placebo. Just like the participants' own, some intervention makes it difficult to blind the therapist. For example, exercise again. If the therapist is going there to give exercise to a group and not give exercise to the other group, they already know that this uh, they already know that the group that these two people belongs to. So that's why you can see in this study the blind blind participants and blind therapists here scored 0 in most of the work. Only few of them have 1. That's because it's very difficult to blind participants and therapists in a study due to the nature of most interventions. Then assessor is one that can be easily be done because you can have somebody who is collecting the data. So before the intervention, this person will come and take maybe their vitals, their social history, check their blood pressure, ask them about their pain, their headache, and everything. But they are just asking this question. They don't know which group these people belong to. So it's easier to blind the assessor. And then after the therapists have gone to do their thing, when it is now the follow-up time to check those values again, the assessor will still come back and collect his data without knowing, even if they are doing exercise, the assessor cannot tell whether this group belong to the exercise group or the intervention group because he will not be there when the intervention will be going on. So that's for blinding the assessor. So for these ones that you have 0 for blinding the assessor, maybe the therapist is the assessor. So the therapist already know the group and he's the one collecting the data. But if you want to eliminate that bias, you should have an assessor that doesn't, this for primary studies, not for us anyway. So you have to have an assessor that will not have knowledge of which group the participants belong to. Then adequate follow-up is about checking whether there was adequate follow-up in the study. So we should be looking at, was there an initial assessment to collect data prior to the intervention? And then was there another assessment to collect data after the study? Then it is expected that after the study, let's say the study was for 2 weeks, it is expected after that 2 weeks, the study was completed, that you've collected data, there should be a follow-up, maybe in the next 1 week or in the next 6 weeks. You ask them to come back again and collect another data. So that is what is registered as a adequate follow-up. So apart from collecting the data at the end of the intervention, there should be an adequate follow-up to collect another data and compare the value or what you are going to get. Then already I've explained the intention to treat analysis. There is one that I jumped, but I have to explain that one before I explain between group comparison. So baseline comparability is that initial value, that initial assessment you collect or you do before the intervention starts. You have to compare the two groups. Even, for example, if the assessor is blinded, he doesn't know which group is the intervention group and which group is the control group, but he have to compare the values of the two groups to make sure that there is no significant difference between them. So if there is a significant difference between one group, already there is a bias because at the end of the day, it will affect the assessment at the end of the intervention. For instance, for example, let's say we have 5 persons in the intervention group of those who wants to take paracetamol and they are rating their pain as 10/10. And then in the intervention group, you have another 5 persons and they are rating their headache as a pain of 2/10. So at the end of the day, if the intervention group take the paracetamol and their pain come down to, let's say, 6/10, and the intervention group that took the placebo, and at the end of the day, their pain still remained 2/10 or even 0/10, because there was a significant difference at the baseline, it has already kind of affected the final result. So there should be a baseline comparability in the sense that this will help guide the interpretation of the final assessment. So if we already know that there was a significant difference at the beginning in a particular group, we will put that into effect. We will be interpreting the final results with caution, knowing that before the intervention even started, this group already had a significant difference compared to this group. So all those things will come into the final result or reporting at the end of the day. So that's why you need to do that baseline comparison. Because if you did not do the baseline comparability and just did the assessment at the end of the intervention, you will now be like, the paracetamol did not work. Meanwhile, you didn't understand the reason that it has actually worked, but because of the difference between the group, you've already somehow you had people who had more severe headache in one group, in the intervention group. So there is no way you can tell. But with the baseline comparability, you will be able to tell that, okay, yeah, initially these people were 10/10, and at the end of the day, they are now 5 or 6. Initially, these people were 2/10, and they are now, so it gives a better explanation and people can understand the results of your findings more better and make sense from it. Then the between group comparison is when you compare the two groups. So usually the between group comparison can be both for the baseline and the final assessment. So you should compare between the groups and also within the group, but within group analysis is not compulsory. It doesn't affect the score. the risks of bias scoring in the Pedro scale, but you have to just naturally, because your work is to compare the intervention versus the control. So there should be a between group comparison, comparing the intervention versus the control. So I would be mad if somebody did a primary study and did not do the between group comparison. That would be like I don't know how to explain that level of fooling. Like at the end of the day, what have you achieved? Like what's the essence of the primary study if you did not compare the two groups? So what are you trying to prove? Then the final one, which is the point estimate and variability, is just also is another thing that if most studies don't have, you will be like, why would somebody do such a thing? It's more about point estimate is about like is like the values. So for most studies, the mean. So each those studies that will be reporting their results in mean, that will tell you uh, intervention group uh, has a mean of, we all know, like those uh, statistical figures or whatever, mean, percentage, what I mean, mode. What's the other one? Mean is same thing as average, mode,
Yeah.
median. So those are the percentage. So they should have all those values, those empirical values to tell us or tell the readers what the findings are. Then variability is the significance difference, the mean error, all those other values, because you are comparing groups, like you have 10 people and you are calculating their average. So you need a variability that will give us maybe this si- what's it called again? Um, Not significant difference, standard deviation.
Oh,
We all know what standard deviation is. So when you
yeah.
have a mean, you are expected to, for a large group of number, you're expected to have a standard deviation that this could run from here to here. But I'm not very good with maths, but at least I have a small understanding of that should be there when you have a mean or standard error or mean error. All those ones are the variability. So most you should expect that most primary studies should have that as well. So at the end of the day, you now add all the numbers. So for this, Tinel et al. 2007 had a score of 6/10, and this other one had 8. This one had 9. So 6/10 should be a moderate quality. So you would say that this study is a moderate quality work. The 8/10 is high quality, 9/10 high quality. So most of them are high quality, just a few are moderate quality. So any work below 4 will be a poor quality work. So this is for Pedro scale. There are a whole lot of other risks of assessment tools out there. So we'll be stopping here. What we'll do is, if we can do the risks of bias, because I just remembered we also need the risks of bias table, something similar like this. And
Okay.
then because it's still what we use to write the results, because at the end of the day, we'll still report that out of the 79 studies, uh, maybe 20 studies were of high quality, or 50 something studies were of high quality. This number of studies were of low quality, and these ones were of poor quality. And then we would also talk about where the bias from each of the study came from. So looking at this table now, most of the bias seems to come from the blinding. That most studies did not blind the participants, and most studies did not blind the therapists. And then you can give a reason why that was the case. So maybe state that it's because of the nature of the intervention that it's difficult to blind the therapist and the participants. And then which other one was also, yeah, I think it's just that blinding that was so significant in this table. To kind of give a rough breakdown. Then if there is one that most of them had like this random allocation, you can state that all 79 studies had random allocation, had between group analysis, had the point estimate. So kind of a breakdown of what you've done in words. Any questions?
No. From me, your explanation was clear and
Okay.
straight to the point.
Yeah,
So
it's clear.
yeah, don't really have much questions now. Maybe later when we'll start
When we
this
start going
mixed
through it
bias.
again.
And now
Yeah.
have some.
Also, when you want to do the Pedro scale for the study, when you go on the Pedro website, there is a PDF form, if I believe, if I can still remember, that have a detailed explanation, what I've just explained now, that will guide you. So if at any point you are thinking, what score should I give this study? Just go back to that PDF or you can ask me. So
Okay.
either way.
Okay. So we are going to outline the 79 works and give them scores individually, right?
Yeah, just like this.
Just like this.
Yeah.
I'll look at it. Okay. No problem.
Oh, let me see the guy.
I was systematic review. Let me trust your guy.
No be play guy. For one walk. Oh.
Oh, one walk. Now I see why you say the more the exclusion, the better.
Thank God, sir. I just do primary study for school, guy. If to say I do this one, guy, time for cry. And I hear no day.
Yeah.
Am I also doing this federal scale?
Sorry?
Am I also doing the federal scale for my work? Those of us that are working on malaria and tuberculosis.
So yeah, you can use the Pedro scale. Also, let me think. You can check out other. So depending on the nature, the type of study you are collecting. So Pedro scale gives more. This is more specific for intervention studies. You get so because these are things you expect intervention studies to do, especially quantitative studies. So any intervention study that is a quantitative study, Pedro's case is perfect for it. But then things like let's say case reports, there are different risks of bias assessment tools for case reports because you are not expecting randomization in a case report. You are not expecting concealed allocation in a case report because you are dealing with a single person or a single group of participants. So you are not expecting between group analysis. So all these things will not be there for you to get data from. So there are other risks of bias tools that we look at ways that there may be bias in those case studies. So what I usually do, there was a time I did one qualitative study on food labels and stuff like that. So I just browsed. I knew I was working with a qualitative study. I browsed about risks of bias too for qualitative study. I saw different ones. I went through them because me, I did like easy things. Found the one that was more easy and clearer to use. Use that one too. So if for your study, I think thinking it should be uh what where are we going to place your study? Because you are looking at comparing the so it's an intervention study because you obviously is it a comparison or was there is there any intervention in that study? I'm trying to think.
There's intervention. We are comparing manual microscopy to computer-assisted microscopy.
Yeah, so there is an intervention there. So I believe, and then it, I believe, I think the Pedro scale should work for your study as well. So it's not a qualitative study. Where
So, sir,
Pedro scale doesn't work is qualitative. Yeah.
the reason why I asked the question was that I saw something about the Pedro scale here when I searched it, and the full meaning was like physiotherapy evidence database scale. So that was why I asked. Maybe it is mainly for studies that are
It's not just for physiotherapy studies alone.
okay,
Uh
sir.
yeah, the Pedro is the website which is physiotherapy evidence database. So it's just a database for physiotherapy studies, but they developed that skill, but I've used it for other uh, studies as well that are not just physiotherapy. But if you want to check, like I said, there are a whole lot of risks of bias assessment skill. You can browse and see other ones and see if there is another one that is, we can just stick to one thing. You can check and see if there is a different skill that may be more suitable. The whole point is for the skill to help you to identify the biases in the study and what level, how did the researchers try to eliminate those biases. So at the end of the day, it will tell you whether the quality of the work is poor, moderate, or high.
Thank you, sir. Really appreciate.
Sir, for the narrative synthesis,
Sorry?
sir,
Yeah.
and for the narrative synthesis, you
Oh,
only
your
make
voice is
mention
keep
of
going.
country, for example.
Yeah, but you mute yourself with the two of you in the same place.
Okay.
Okay, Bankole.
For the narrative synthesis, you only make mention of the country, for example. Say maybe
So
there were two studies that were done in
those
UK and so on. What are other things that you can also mention?
so the what we are doing so far is the uh narrative synthesis of the result. So what I said we are going to do for the country, just finding an empirical figure to explain to so that if somebody want to read rather than looking at the table, if they go through what we've written, they will know, okay, out of the 79 studies, 10 countries, uh, 10 studies were from US. So for the sample size, we will also give an empirical evidence of the sample size, tell them the total sample size, tell them within the sample size, how many of them are female, how many of them are male, and then also tell them the intervention, the number of intervention within the 79 studies, the different, for example, we can say out of the 79 studies, 10 studies where these carried out this type of intervention, 12 carried out this type of intervention, 7 carried out this. So it's kind of breaking down, explaining those values in the table with figures, like you are writing it down. I don't know if I shared a previous study with you guys before, just to give you an idea of how the what the result looks like, or you can just browse any systematic review, read through the results. They follow the same pattern, like I explained that earlier. Is a systematic process and it has a guideline. So most people will follow a similar pattern. So once you read the results, they are just telling you that they have this number of population. These are where the studies came from. These are the different things in the study. So giving empirical values for each of those data you've extracted.
Yes, sir. Thank you,
I
sir.
don't know if that, like, it's just, I don't know if you understand that.
Yes, sir.
Okay. So the easiest way is just look at the results section of published systematic reviews, and then you have an idea of what they've done with the table.
Thank you, sir.
All right. Any other question? William, you are still muted.
Okay.
Yeah.
Any other question?
Okay, none from me for now, at least. Let's narrate the ones we have done so far, and maybe as we progress, hitting you up for guidance.
Let's go and do that one.
Yeah, so
Okay.
the task now will be to complete the risks of bias and then write the results section.
Okay. So the result section, are you writing it in that what's the name of that app? That place we wrote the proposal, I think.
No.
Postgrad one.
MS Word. No.
Okay, write it in MS Word.
Yeah, in Word. Yeah.
Okay. Okay, it's all right. So after writing it in MS Word, are we going to join that Prospero this thing together with it? Like copy it out?
I will have to go back to that the ones you sent me just to check.
Okay.
Just to check, because I'm very sure that our chapter 3 is not yet well written.
Well written, okay.
But that protocol is mainly chapter 1, so we don't have to rewrite the chapter 1 again.
Okay. It's all right. So after chapter 4 now will be discussion now, right?
Yeah.
Okay. It's all right. No problem. Thank you so much for your time and sacrifice. May God bless you, sir.
And bless you too. Hope
Thanks so much, Sir Victor.
Thank you,
We
sir.
really appreciate it.
Thanks.
Thanks so much.
Okay. Send our regards to your lovely wife.
I will.
Okay, boss. Okay. Thank you.
All right.
Okay. Have a blessed day.
And you too. Bye.
Okay. Bye. Ogabo.
Sir Wills, have fun now.
Hope you learned something today. If you get the
No, it's going well. It's going well.
It's going well. That is what. So after we go plan on how we write this result.
No wahala.
Well, AI fit do most of these things. So very simple, like